Does voltage and voltmeter mean? You might be wondering, why do we want to learn that? That's a great question actually. Voltage, it's very good, like it's for electrical engineering, I guess. Okay, let's start the video. Okay, now we are going to learn what is the main source. What is a main source? The main source of electricity are cells. No, those little cells they come in, where one is written like this, other one goes like this, and something, yeah, something like this. They go, yeah, these are called cells. Cells and batteries and generators. Main source of electricity are cells. Cells. I just told you this. Batteries. Batteries, right? Batteries are the same thing, I guess, but yeah. And generators, generators, how generators are. This mechanical thing going on here, boost, gives energy to them. Okay. A continuous path between two terminals of a battery is called electric circuit. Two terminals. There will be two terminals here. Okay, just a continuous two path between two terminals. Now the continuous path between two terminals is called electric circuit. How to connect a bulb, right? To connect a bulb to a ammeter. Wait. Let me just. An ammeter is like, right? Ammeter is basically like this. It goes like this, and the A is written here. What is written here? A. And then there's a minus sign here, and then this plus sign, as I remember, I guess. Yeah. To connect this, to connect a bulb. A bulb is like, let me just show you. Bulb is like this. My drawing is bad, I agree. Yeah. To a ammeter, let's just make it like this: minus plus A. For that, then connect then to a battery. Then connect one battery. How battery is like, right? Battery is basically like this, and then this small one, and then this big one again, and this small one, and this big one, and then there's this thing, and then it goes like this, and then here's the plus, I guess. I remember this. Yeah. To then one battery, two batteries, and then three batteries successively. One battery here, and then two battery here. Wait, I'll just show you. Like manually, not like that. Altimeter is like this. There's like plus here, and then there is A here, and then there is minus here, and then go like here, and then there's a fuck. Sorry, my language is bad. Plus here, and then there is minus here. Sorry, minus here. Then there is a bulb here, I guess. Shit, drawing. Then two batteries. How batteries are, right? I just showed you batteries. I'll do it again. Just assume this is a battery, and then there's another battery here. Yeah, it's like this. What I told you, right? A bulb here. Let's just assume it as B. Okay. I want a drawing. Okay, I'll give you a drawing, and then this is ammeter, and this is the battery. I'll just write you here B, and then connect here again to the bulb. That it is connecting a ammeter to a bulb, basically. Yeah, they just told that. Observe the reading on ammeter in each case. Okay, there's one battery here. Okay, B. Wait. There is one battery here, and then A here, and then again wait, uh light bulb here. Let's just take it as L. And then in this case, this, okay, light bulb, it won't be that, like bright. Okay, observe the reading of ammeter in each case. Also the brightness on which the bulb goes in each case. Okay, there's this is called common sense. When there are batteries, one battery will equal to more voltage in ammeter. It will go from one battery here to light bulb here. It will lead to like less voltage here, right? If this is a scale, this will lead to less voltage, right? I'm doing all this on memory, so it will be bad. I'm sorry. I'm very sorry. Plus, minus. Okay, it will be very bad, right? It will be very low. But, if you add two batteries you add, and then you get a ammeter. I'm doing on this memory too. Shit. It will be in the middle section. Yeah, it will be in middle section because like, if this is bad, this will be okay. And then there'll be a bulb here. Yeah, it's like this. So yeah, it will, two batteries, of course it will lead to better, better voltage. And then it of course this will like go brighter. This will go brighter, and this will become medium because there are two batteries. One battery equals worse, two batteries equals better than last one and brighter this. And then let's observe what they said. Well, let's demonstrate what three batteries looks like. This is a drawing. Just bear through this thing. I'll give you a video to this. Okay, there's an altimeter here, and then it goes maximum. Three battery, it goes maximum. I'm doing this all on my memory, so yeah. And then there'll be bulb, yeah, and then yeah. So this will glow the brightest, right? Because there's more batteries here. The more the battery, the more the voltage. So they'll pass like this. So the altimeter go full. It will experience the most, So also note the brightness. I told the brightness when the number of batteries are increased. Now we increase the batteries from 1 to 2 to 3. The electric current increases. Batteries, they have like current in them. It's a common sense. Like, they have current in them. It makes bulb grow. How do bulb glow? Because of batteries, electric currents, and it glows more brightly. Ammeter, it like, it will like measure how much voltage there is, because one battery is low, more battery, I mean moderate, and three batteries is max, so it will go max, I guess. Just for the reference, this ammeter, it will be like 2, 4, I'm guessing here 8 and 10. So maximum is 10 voltage. So at 3 batteries would go 10 voltage. 3 batteries are 10 voltage, I'm guessing it. Okay. If the battery is 1.5 voltage, okay, 3 batteries will lead to 1.10 voltage. If it is 1, it will lead to like, I don't know, 4 or something. 1.5. Yeah, I'm not going to calculate. I'm very bad. It will probably, the 2 means 1.5. The ammeter records increase in current. Yeah, I just told you that. In friends, Batteries or electric cells push electricity round the circuit. You know what circuit is, right? You know how circuit works, right? I'm sorry. You know how circuit is, right? Circuit. Wait. Let me just show you the circuit. There be a circuit here. More cells connected to series push greater is called voltage. The more you push there, the greater the voltage. The more voltage there is, the greater the push it is called. So I'm sorry. Voltage. Wait. Okay. Voltage is measured in volt. You know how voltage looks, right? There's got a circle and there it is V and then minus plus. Voltage is measured in volt. This is measured in volt. V. Always remember that, okay? Voltmeter. You know what voltmeter it is, right? Are used in voltage. The voltmeter are used in, voltmeter looks like this. They're used in voltage, are connected in a circuit in parallel. You know how parallel, this is parallel, okay? They're connected in a circuit like parallel shit, okay? Voltmeters are connected in a circuit in a parallel method. No parallel are there. It is like, right? There's a bulb here. From memory, I'm guessing there's like a, battery here, and then it goes like this. Then this goes here, and there's like a voltmeter here, V. Then this will go here minus. This will be plus. Yeah, this is basically like what they're trying to convey. One batteries, two batteries, three batteries successfully. Like that case I just showed you. You can increase the batteries like this. And then there's like a bulb here, then it goes here, this will come here, and there's like a voltmeter here. Yeah, it will increase like this will 2 and 3 successively. Observe the reading on voltmeter in each case. So it's like just like the first one, okay? It increases successively, like from 1 it will be like 0, 2 or 4, it will become 5, and then it will become 10 because of 3 this thing. It is, but they both are like in parallel shit. It is the same thing. Also note the brightness in each case. It's like the previous one, but they both are parallel, okay? It is connected to ammeter in both ways. The bulb is connected to the ammeter in both ways, and the battery is also connected to the bulb in two ways. That's called parallel shit, okay? Observation when number of batteries are increased. When battery increases, the voltage increases, and then the bulb glows brighter. All the light rays speeding, light speed going like this, trillions of millions of infinite light rays coming through the light. It goes there, boom, it becomes brighter as the batteries increase. Oh my god, it becomes so bright. I'm blinded by the light. Oh no, my eyes are hurt. I'm crying. Oh, oh, oh. Okay, enough drama. Okay, and then the voltage increases. Yeah, shit. Let's learn the new topic. Electric power. Electric power. Electric power. Power. Let's go, bitch. Electric power. Okay, the electric power of given device is rate of doing work or amount of electric work in 1 second. The rate of doing work. The rate of doing work. Electric power can be like defined. I'm guessing is like. Oh yeah, it is here only. Electric power is equal to work by time. So E equals work by time. Electric power is basically work by time. It's very basic. Like E electric power is equal to work. Work by time. Rate of doing work. Rate of doing work. Amount of work done by in 1 second. How much work it does. It goes like this in 1 second. 1 singular second. It's called electric power. Let I be current ampere flowing through conductor for 10 seconds. Time let through a conductor for time t. Okay. Okay. It's called t seconds. Then according to the definition of power, electric power, E is equal to work by time. They just explain what it is or how to do this. If V is potential conductor, then if V is potential conductor, difference across the conductor, then electric power is equal to the product of voltage and current. You know what? You understood that? No, you understood that? You didn't understand, right? Okay, the I is like ampere of current flowing, okay? Ampere of current flowing, so it defines the amount of current flowing. So this will become E, okay? E will become V. V is right. V is potential conductor. Potential current. What does potential conductor mean? You know what potential conductor means, right? No, I need to explain. Okay, fine. E is equal to V. I just told what E means, and then I into T. Time. What T means, right? Why time? What happens when this thing happens? This cancels out. The time cancels out. And what do we get? what do we get? We get E is equal to V I into I. Vi can be like, we can just say that vi is equal to like joule by second. I just invented that. Did I invent that? Oh no, I didn't. I just remember. Joule by second. What can we say joule by second is? What do we say joule by second is? Just guess. What? Joule by second is what? Damn. So electric power, EV take E, is equal to P. That's crazy, right? That's crazy, bro. So E is basically just VI. And then electric power is equal to product of voltage and current. That's what they told, but they didn't give the like formula to explain you. So I just gave you the formula right there. E equals VI, because T and T gets cancelled out, so you get VI. Just don't complicate it, okay? VI, product of voltage current. What is a unit of power? Hence it can be expressed in terms of volt and an ampere of volume of electric power. It can be explained the like flow of electric power. So how do we do that? How do we do that? W can be written as 1W, to be specific. Okay, 1W can be written as 1 volt into 1 ampere. That's crazy, bro. So we can just write 1W equals 1 V into 1 A. So just, if you multiply that, what do you get? 1W equals 1 VA. Voila. Voila bola. Voila. W equal to VA. What? Just add one there. W. Dumb scientist. Okay. Voila. What is VA? V fucking A. Voila. Volt into ampere. Damn. That's crazy. If potential difference of volt causes a current of ampere to flow through a conductor, if 1 volt causes, it causes 1 ampere to flow. You know how flows, right? You know how it flows through a conductor. Conductors, right? Like copper. Okay. What makes ampere go through a copper conductor? Okay, copper conductor. Yeah. The electrical power consumed is what? We just learned that. Isn't that like crazy, bro? Isn't that like crazy, bro? Oh my god! Oh my freaking god! How can that be true, bro? Science is so elegant, man. Physics is so fucking elegant. Oh my god, elegancy, man. I love physics elegancy, man. Physics is elegant. I love the elegancy. So they're just telling. They just defined that like crazy, bro. They just casually defined how that works. Just just take a volt. 1 volt, okay? It affects a 1 ampere through a conductor, okay? It flows through a conductor. And then the electric power consumed is a watt. Freaking watt. Isn't that like crazy, bro? Oh my god, this is Eureka. Man, science is so elegant. Except biology. Yeah, it's not elegant. So freaking elegant, bro. I mean, I can't like, believe it now too. Like, this is crazy. How can people not know this? How can people not know this? Okay, let's just move on. I mean, people might think I'm crazy. So, okay, let's start from here. Larger unit of commercial energy, which electrical energy sold to consume kilowatt hour or kilowatt ampere hour or board to trade unit. Bot, bots, right? Bot from games. Board of trade unit. Board of trade unit. Just learn that shit. Board of trade unit. Large unit, large unit, big unit, small unit. Teeny weeny small unit. Okay, this is the bigger unit of commercial energy at which electrical energy is sold to consume. To consume is called when you consume that, right? It's called kilo hour. Okay, kh, I guess. Okay. Okay, let's just do it again. 1 kilo hour, okay? It is equal to 1 freaking kilowatt hour. Oh, freaking god. 1 kVA. KV. Whoa. What am I seeing? If I just add 1 here, isn't that what shit? Isn't that what thing? Oh my god. 1 K V A H equal to 1 kilo hour. Oh god. Oh god, this is crazy. Oh god, this is crazy. Okay, let's just wrap things up. In practical applications, the units of power are used are kilowatt, megawatt. Mega, 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 mega. You know Mega Man, right? Mega, 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 megawatt, 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 megawatt. horsepower. Horsepower. Yeah, horsepower, HP. Yeah, don't do that. The graph shows how an electric lamp, no electric lamp, right? Electric lamp converts electrical energy into heat. Wait, what the freaking hell? Am I dumb or something? Am I dumb or something? Into heat. Okay, beat. Fucking hell. It's not beat. Okay, it's heat. I'm sped. And light energy at rate of 100 joules. Freaking joules per second. You know, electric lamp. Okay, the mighty electric lamp. It converts. Okay, the mighty frick. It converts. Okay, electrical energy, the electrical energy that just comes here, it goes inside. It how the electric lamp converts electrical energy. This is just electrical energy, okay, into heat. When you like touch this shit with your, yeah, wait. When you just touch this shit, you get hot. Oh boy, sob. Oh my god. Shitty hell. You get hot. Not hot, bitch. Hot. Oh no. Ah. This is like basically like turning literally electrical energy into heat. Into actual freaking heat. You get heat, right? You touch it, you get heat. Just don't try it at home. Like, don't be like crazy like me. Just don't touch it, okay? It will be hot AF. Okay, there'll be heat into heat and light energy. Of course, a lamp's job is to produce light. Of course, but heat energy. Damn, that's another level, bro. Who invented lamps, bro? Like, crazy, yeah. It will be a heat here and then light. Beam, light beams. Beam. Billions of trillions of light beams, which is just helped us a lot. I mean, we can't see without light. Speed of light is the fastest thing in this universe. So, lamp literally creates it. That's like crazy invention, bro. That's like crazy, bro. That's like the craziest thing you can do, bro. Like, it will be the best. It was the best idea, I guess. I'm guessing. Therefore, at rate of 100 joule per second, it converts electrical energy to heat and light energy at rate of 100 joules. Electrical energy into heat plus light. Therefore, power of the lamp, the power of the light bulb is 100 watt. ओ भाई साहब, क्या फंडा है यार. Okay, we learned that watt is equal to VA. So just divide 50 by something. 50 divided by 2. 2 ones are 2. Okay, 2 twos are 4. I'm dumb. 1 here and then this goes here. And then 2 fives are 10. Oh bhai sahab. Oh bhai sahab. Oh bhai sahab. Energy converted at rate of 60 joules per second. 60 freaking joules. per freaking second. The power of lamp is 60 watts. 60 freaking watts. 100 joule per second is 100 watts. So watts is equal to J by S. Oh my god. Oh my god. Oh my god. Okay, I'll explain how it works, okay? This power, okay? Work by time is equal to power joule by second. So power is equal to joule by second. So if it's 100 by 1, no, second is 1, right? 1 second. I just told you that. Electric energy is like 1 second, right? So 100 by 1. What does 100 by 1 mean? 100 watts. Power is just what? Power is equal to what? Yeah, it is all I know. Yeah, thanks for watching video. This mediocre fucking piece of shit video. I'm very sorry to curse. Yeah, bye. I hope you study well.